This is lesson 7.10, using the trig ratios sine, cosine, and tangent. And this is just a review of the two lessons, 7.8 and 7.9, that you learned recently. So we are going to find the value of x, which is going to be one side of a right triangle. We're going to use this process right here, and this will be the same on your assignment as well. So we're going to label the sides with opposite, hypotenuse, and adjacent. We're going to choose the ratio and write it out, and then we're going to plug in and solve. So here's our first triangle. It is a right triangle. We have a 53-degree angle right here. We know this side is 15, and we're trying to find this other side over here. So remember, the way we want to process through this is we want to first start by saying which side is which. So we're going to use O for opposite, A for adjacent, and H for hypotenuse. We know across from the right angle is always the hypotenuse. We know opposite, the side opposite that angle that we know is the opposite side. And adjacent means next to, so the side that is next to the angle that we're looking at that's not the hypotenuse is the adjacent. So now what we want to do is choose the ratio that we want to use. Is it sine, cosine, or tangent? Let's remember a mnemonic device that can help us. Remember that sine is opposite over hypotenuse, and we say so, S-O-H. Cosine is adjacent side over hypotenuse, so we can say ka. And then tangent is the opposite side over the adjacent side, so toa. So ka toa. Well, if we look back at this example here, the side we're trying to find, let me use yellow here, the side we're trying to find is opposite. The side we know something about, this side that's 15, is adjacent. So which trig ratio are we going to use? Well, we're going to use the one with opposite and adjacent in it. So tangent. Tangent, remember, is the opposite side over the adjacent side. So we're going to say the tangent of 53 degrees is equal to, the opposite is x, and the adjacent is 15. To solve this, I typically will use a proportion, and I cross multiply. X times 1 is x, and the tangent of 53 times 15, hold on. Tangent of 53 times 15 is what we're going to find here. So the tangent of 53 on our calculators is 1.327. If you get a negative value, it means your calculator is in radians, so talk to me about that. And then if we multiply by 15, we end up with 19.906 when rounded to the thousandths. So that's what the missing side's length is. All right, we're going to just review a couple more, and we're going to do the same process each time. So the first thing I'm going to do is look at what angle I am given. That's this 25-degree angle. And we're going to label our sides based on that reference angle. So the hypotenuse is always across from the right angle. The opposite is over here. And the adjacent side is next to the angle that's not the hypotenuse. So based on this, again, we're going to think about what I'm trying to find is the opposite side. What I already know is this 41 unit side here, which is the hypotenuse. If we write so ka toa, it might help us realize what we're going to need is, again, the side with opposite and hypotenuse. So those are the ones I circled, so we're going to use the sine ratio. So the sine of, again, theta we use sometimes is that Greek letter for an angle. The sine of theta is opposite over hypotenuse. So sine of a 25-degree angle is equal to the opposite, which is x, over the hypotenuse, which is 41. Now, in this example, we are once again solving when x is in the numerator, so it's going to be very similar to the previous one. X times 1 is x. And then here we need sine of 25 times 41. And we're going to go ahead and finish this up with our calculator. And when we take sine of 25, we get 0.423, and we multiply that by 41. and we're going to get 17.327. Now, just so you know, some of our results will maybe differ a little bit in the hundredths or thousandths place, depending on when we round the sine of 25. So that's why we always go to 3 decimal places, because then at least this first 3 digits are typically very similar in any person's results or answer. All right, let's try the next one. And actually, before we do, I want you to change something on this example. I would like you to change this 20 to x and change the x to a 20. We're just going to switch them around because I want to remind you about what to do if our variable x is not in the numerator. It was in the numerator for both of our first 2 examples, and this one would have been the same. So let's do it this way. All right, so we're going to start by labeling our sides. The hypotenuse is over here. Notice I changed that to x. The 60-degree angle across from it over here is the opposite side, and then we have our adjacent side down here. Again, if we think about what am I trying to find? Well, I'm trying to find x, which is the hypotenuse, and then I have the adjacent side that I know is 20, so I'm going to circle that. The trig ratio up here that uses adjacent and hypotenuse in it is cosine. There's adjacent and hypotenuse together. So I'm going to say I'm going to need the cosine ratio for theta, that's our angle, and cosine is adjacent over hypotenuse. So cosine of the 60-degree angle is equal to the adjacent side, which is 20, over the hypotenuse, which is x. So now we have our variable in the denominator. I'm going to put that over 1 and cross multiply to solve. So 20 times 1 is 20. Cosine of 60 times x looks like this. Now, some of you, I think your teachers might have asked you to actually compute this on your calculator before putting it in your equation. I don't typically do that. Either way is fine. Our results might come out to be slightly different. So now we are going to divide both sides by the cosine of 60. And I don't know if you heard my doorbell there. Go ahead and cancel out the cosine of 60 on both sides, and we are going to get x equals 20 divided by the cosine of 60. If you type that out on your calculator, cosine of 60 is actually 1/2, so 20 divided by 1/2 is 40. So our missing side is 40.